So right, my friends, if I am not wrong, the last time when we met, right? When we met, we almost started with this, say for example, temperature inversion. That's what our record says, right? So we started with temperature inversion. So after completing this temperature inversion, we talked about atmospheric pressure. Okay. So what is this atmospheric pressure and how we classify them, right? And when I talk about atmospheric pressure, how exactly this atmospheric pressure is, say for example, distributed globally. Collectively, you call them as what? Pressure belts. So in that regard, we talked about the 7 pressure belts of the world, right? Where what type of pressure belts we have, approximately we have an idea. So after talking about this pressure belts, my friends, we started with one very important concept. We were calling it as what? Wind, my friend, right? So what is a wind? See, for example, somewhere we said wind is nothing but what? Horizontal movement of an air mass, you call them as what? Wind. So one air mass moving from one place to another in a horizontal fashion. So where to where this wind moves, always we said the wind moves from a high pressure to a low pressure. Okay, right. What is the causative factor of this wind? That also we have justified. Am I right? We have seen. What is the causative factor of this wind? Pressure difference. Am I right? What causes this pressure difference? We said it is convection. What causes this convection is what? Temperature. So temperature results in convection. Convection results in pressure, and pressure results in what? Convection. Right, my friend? So having said that, we have classified wind on its right side, the place where exactly it flows and the size, what exactly is the area that covers. Right, we have classified wind as surface and upper air wind. Right, given the area that it covers, we have classified them as planetary winds, regional winds, and local winds, my friend. Right. So with that, we also talked about the regulators of the wind. Right, what are the very important regulators we have? Correct. When I say regulators, right, somewhere we are talking about those factors which is responsible for, right, say for example, causing the properties of a wind. What property? Right, the direction of the wind, velocity. That's what we call them as what? Regulators. Correct. So we have talked about some very important regulators, my friend, like pressure gradient force, like Coriolis force, a very interesting force rather, I would say, right? Then we have talked about frictional drag, right? Frictional force, as simple as this. And finally, we talked about, right, gravity, my friend, right? How exactly gravity plays an important role in, right, determining the flow of a wind. I said that the gravity I have not explained. Maybe I told you that, okay, somewhere later, right, I'll be talking about gravity, right? When example strikes, we'll be taking the case of what? Gravity. So, my dear friends, today's class, what we have to do, right? Things are very simple. We have to proceed further, right? So one by one, every wind we have to take it, right, and we have to discuss in detail, my friend. So we'll be discussing about planetary winds. I'll be starting with planetary winds first, right? But then from there I'll be directly going to what? This local winds, my friend. Regional wind, I'll just leave it for the later stage. Why? Because when I talk about regional winds, right, we'll be discussing about what the concept called as monsoon, my friend. Okay. Then we'll be discussing about jet stream. Again, after completing all these small topics, right, we'll take the case of monsoon. Okay. Right, my friends, this is what we are going to do. Okay, one by one we'll discuss. Okay. So today's class, right, we'll start with planetary winds. And I'm telling you, planetary winds, the kind of questions that is asked in examination is very simple, my friend. Very simple. Okay. We'll also see some of the questions that is asked in the examination. Okay. And the only thing is that we'll be taking slightly, we'll be almost adding more informations to it. Okay. So, if my understanding is right, this is what we have done in the last class. So, we are going to proceed further, my friend. Okay. Right. Right. So as I said, I'll start with planetary winds. See, when I talk about planetary winds, somewhere if you remember, my friends, we talked about the 7 pressure belts of the world, right? We talked about the 7 pressure belts of the world. And in that 7 pressure belts, between the 7 pressure belts of the world, we had 6 planetary winds which were right flowing between them. I'll just show you. Okay. Simply, we are going to talk about these winds, my friends. See, all these pressure belts we studied. The last class, the earlier class, we studied about this pressure belts, my friend. Okay. Now what we are going to do, we are going to discuss about those wind which flows between these pressure belts. So I am of the opinion, right, that you know the locational aspect of this pressure belts, my friend. Okay. So somewhere I just believe, right, I strongly believe that you know the locational aspect. So given the locational aspect of the pressure belt, now I can construct the wind, because I know the fact that wind always moves from what? A high pressure to low pressure. Okay. Right, my friend. So in that regard, so what I'll do, okay. So I talk about the planetary winds between the 7 pressure belts, right? What you have is what? 6 very important planetary winds. See why it is called as a planetary wind? Because this wind covers the entire globe, my friend. Correct? Right. It means 6 wind put together, almost it covers all part of the world. That's the reason it is called as what? Planetary wind. Okay. Right. In that regard, my friend. Right. Again, I'm telling you, I'm assuming that you know the locational aspect of all these pressure belts. Okay. Maybe in short forms, I'll write it. Okay. See, these pressure belts are not line. This is a region. Okay. But for simplicity, I am just considering this as a line. Okay. And you know the fact that every 30 degree you travel north and south, there is going to be alternate sequence of pressure systems. Okay. In that regard, my friends, 0 degree, correct? This is where I have what? Equatorial low. I'm not writing fully, assuming that you know it, correct? 0 degree. See, I'm just replicating this image, my friend, nothing else. Okay. So 0 degree, what you have is what? Equatorial low, correct? 30 degree north and 30 degrees south, what you have is what? Subtropical high, correct? What you have is subtropical high. 60 degree north and 60 degrees south, what you have is what? Subpolar low, my friend. What you have is what? Subpolar low, correct? 90 degree north and 90 degrees south, my friend. What you have is what? Polar high, correct? I'm just writing in shortcuts so that it means assuming that you know it, right? Because see, everything I have just mentioned, the only thing is that I'm just writing in what? Shortcuts. So every alternate 30 degree you travel north and south, you encounter alternate sequence of a pressure system, correct, my dear friends? You know the fact that wind always moves from what? High pressure to low pressure, correct? So somewhere, right, let me construct it, my friend, assuming that, okay, you know the fact that the wind always moves from what? High pressure to low pressure. Okay. So assuming that this is how this wind should be moving, my friend. Okay. Circles are the source region. Right. Arrows is the direction, how exactly it is moving. Am I right? So somewhere, my friend, assume that I'm just putting double arrow. Okay, so that you'll not get confused. Okay, single arrow should be fine enough. Right. My dear friends, this is how this, say for example, wind should have been moving. Okay. This is how this wind should have been moving, but you always know that you come across a very interesting force called as what? Coriolis force, right? Right. See, wind, see, for example, again, for your reference, the dark, okay, I'll use this word, it's okay, this, some other color. All that circled, right, regions, my friend, these are high pressures. Wherever the arrows are converging, they are low pressures. Okay, my dear friends, you have to tell me, correct? I have constructed only with the pressure gradient force, but you always know that any moving unstable mass comes under the influence of Coriolis force. If that is the case, you have to tell me a very simple, means answer for a simple question, my friend. What exactly is the direction of deflection of any wind that is moving in northern hemisphere, my friend? Which direction it gets deflected? That's the question. Right. Which direction it gets deflected? Very good. Right. It gets deflected towards what? Right. Am I right? So very carefully, if I am just constructing, right? Say for example, right? In northern hemisphere, my friend, the wind gets deflected towards what? Right. Okay. The wind gets deflected towards right. Okay. So very carefully, I'm just writing it, my friend. The wind gets deflected towards what? Right. Okay. And my dear friends, what is very important here to be noted here, this right is not your right or my right. This right is with respect to the movement of the wind itself. See, the wind which flows between 30° and 60°, I have constructed, right? I don't have a problem here. Okay, I don't have a problem. But problem comes in when I talk about, say, for example, constructing the rest of the wind, my friend. Okay. This is how the wind actually flows, right? It gets deflected towards what? Right. The deflection is towards right. Right, my friend. Now you construct the rest of it, my friend. Now you construct it. Now see, the deflection is towards right. The deflection is towards right. Now this is the reason I said, when I say this right is not our right, my friend. This right is with the movement of the wind itself. Correct? Very important. This is where your aptitude, common sense, you have to apply it. Am I right? So somewhere, if I just talk about, say, for example, right, a wind which is moving, coming from higher latitude towards a lower latitude. Am I right? So while it is coming, it is getting deflected towards what? Right. That's how you should take it. Okay. Right, my friends. Now somewhere I have constructed it. Similarly, if I'm just applying the same logic in southern hemisphere, my friend, I'll tell you at the end of this discussion, I'll tell you that how to remember the direction of the wind. Okay. So if you're there in southern hemisphere, you know the fact that deflection is towards what? Left. Okay, the deflection is towards left. Towards left. So my dear friends, we have constructed the actual direction of the wind. Okay. And my dear friends, you always know wind is anytime, when I talk about naming of wind, wind is always named from where exactly it comes from. Right. If you ask me why, reason is very simple. Because we are not very sure that where exactly the wind is going. At least we know that where exactly the wind is coming from. Correct. Logical, my friend. When I talk about sea breeze means what? A wind which comes from the sea, you call them as what? Sea breeze. What is a land breeze? A wind which comes from the land, you call them as land breeze. Mountain breeze coming from the mountain. Valley breeze coming from the valley. Southwest monsoon coming from southwestern direction. Northeastern monsoon means coming from northeastern direction. So, what is the logic? Logic is very simple. Wind is always named from where exactly it is coming from. Okay. Because again, I'm repeating it because we are not very sure. We do not know where exactly the wind is going. Right? So, if that is the case, my dear friends, you have to tell me, right? I'll give you the name of this wind. Okay. See this wind, say for example, the lower latitudinal wind, you call them as what? Trade wind, my friend. I'll tell you why exactly it is called as trade wind, why exactly it is called as westerly, everything I'll tell you. The mid latitudinal wind is called as westerly. Okay. And the higher latitudinal wind is called as what? Polar wind, my friend. It is called as polar wind. The only thing is that you have to tell me what exactly is the direction in which it flows. One by one, I'll ask you. Very simple. All right. I'm simply asking you, my friend, if you're there in lower latitudes, this wind is called as trade wind. Now you have to simply tell me what exactly is the direction in which it flows. I'm telling you, wind is always named from which direction it is coming from. You have to simply tell me which direction this wind is coming from. Give it a try, my friend. Simple. See, I know the fact, right? This is what the wind is all about. And if I just construct the directions, you know what exactly is the direction: north, south, east, and west. If that is the case, my friend, I understand, right? This particular wind is coming from what? Which direction? Question cannot be simpler than this. Trade wind comes from which direction? Again, I'm telling you, source is very important. Always name it after the source, not to the destination. I'm simply asking which direction it is coming from. Very good. It comes from northeast in direction. See, north and east. It comes from northeastern direction, my friend. So if you ask me what exactly this wind, how exactly this wind is named as, right? This wind is named as, right, northeastern trade wind, my friend. Right? This wind is called as what? Northeastern trade wind. Okay. And similarly, my friend, apply for this wind, right? This wind is called as westerly. I'll help you out. Okay. This wind comes in this direction. Okay. I'm just replicating this image. Okay. Now I'm constructing the direction, my friend. North, south, east, west. So idea is this wind comes from which direction, my friend? And talk about westerly. Westerly comes from which direction? Very good. Southwest. Am I right? That's the reason, my friends. When I talk about westerly, you call them as what? Southwestern westerly. Right. You call them as what? Southwestern westerly. Correct? So why it is called as northeastern trade? Why it is called as southwestern westerly? We have an idea. And simply when I say polar winds, what exactly is the direction from which it comes from? It is northeastern polar winds. Correct? And similarly, if you construct for the southern hemisphere, it is southeastern trade, northwestern westerly, and it is a southeastern polar wind, my friend. It is southeastern polar wind. Okay. So these are the direction of the wind. Okay. So first and foremost, I should understand why a wind is called as a westerly and easterly wind. See, for sometimes a few of the books you read, you will come across the term called as, they call them as what? Easterly trade wind. Even the diagram, the image, what we have taken, okay, they have not given it. Somewhere, if you remember, I see here, northeast trade, southeast trade. Okay, why it is called as northeast trade and why it is called as southeast trade, we have justified. Now, why it is called as polar easterly, that also will justify, my friend. Now, what we have to understand, among the 6 winds, now what I'll do, I'll just remove this, say for example, I'll just remove this north-south divide, my friend. Right, I'll just remove this north-south divide. Okay, I'm just removing this north-south divide. Okay, I don't want this north and south divide. Right, my friends, I don't want this north and south divide. Now, if that is the case, now I have a wind which flows either from easterly or eastern direction, or a wind which comes from western direction, my friend. So any wind which comes from the east, correct, you call them as what? Easterly wind, my friend. So you have to tell me, in that situation, you have to tell me, what are the winds which comes from the east, my friend? Right, that wind which comes from the east, you call them as what? Easterly. Right, on your behalf, if I'm just asking, the winds which comes from the east, right, they are trade winds and they are polar winds, my friend. Right, that's the reason trade winds and polar winds are called as what? Easterly winds. Right, trade winds and polar winds are called as what? Easterly wind. Why exactly it is called as easterly trade? Why it is called as polar easterly? Because they are easterly wind. Correct. Now comes the question, what is the only wind which comes from the westerly? Which comes from the west, my friend? You have to tell me, what is the only wind which comes from the west? Forget about north and south. We are worried only about what? East and west, my friend. Okay. The only wind which comes from the west is what? Westerly, my friend. That's the reason this wind is called as westerly. Because among the all 6 planetary winds, right, the only wind, okay, see, Every time I say 6 winds, but when I talk about the names is only 3. Polar winds, westerly and trade winds. Right? Among the 3 names, the only wind which comes from the west is westerly. That's the reason you call them as what? Westerly. A wind which is not westerly, you call them as what? Easterly. So what is easterly and what is westerly? Simple, my friend. Any wind which comes from the west, call it as westerly. Any wind which comes from the east, you call it as easterly. That's it. So simple it is. Okay. Now comes the question. How to remember this direction? See, is it necessary to remember the direction? No, not that much necessary. But somewhere we'll try to understand, because once you remember the direction, understanding Indian monsoon becomes very easy. Okay. I'll tell you that somewhere you find a kind of correlation or right repetition, my friend. Right. I'll tell you what it is. Say, for example, if you're there in northern hemisphere, you find the wind flowing in only 2 directions, my friend. Either a wind will be flowing in what? Northeast in direction, or a wind will be flowing in what? Southwest in direction. Now, somewhere you do not know the concept of monsoon, but somewhere try to relate the concept of monsoon. And about Indian monsoon, I have 2 monsoons, my friend. Can any one of you tell me what are the 2 monsoons we have? What are the 2 monsoons we have, my friends? Any idea? See, geography, somewhere every day you see it. Very good, fantastic. Northeast and southwest monsoon. My friend, see again, see the similarity. Either you will be having a monsoon which is northeastern monsoon, see here, right, somewhere you're seeing it. Either I have a monsoon which is northeastern direction, or I have a monsoon which is southwestern direction. My friends, any large area winds which flows in northern hemisphere, either it will be a northeasterly wind or it will be a southeasterly wind. Okay, that's it. Now comes the question, how to remember this direction? That is a $1 million question, my friend. Simple, right? Somewhere you can write it, my friend. Okay. Somewhere I'm just giving you one statement, you write it. That's final in itself. I'll give you the statement now. Somewhere you can write it. Easterly winds, I repeat, easterly winds are hemisphere specific. That is, easterly winds of northern hemisphere will be northeasterly and of southern hemisphere will be southeasterly, and of southern hemisphere will be southeasterly. I give you a statement, my friend. Any question asked, you can answer it. Simply I'm saying easterly winds of northern hemisphere, right, will be northeasterly. What are the easterly winds? Trade and polar winds are the easterly winds. So polar winds of northern hemisphere will be northeasterly. Trade wind of northern hemisphere will be northeasterly. So, and of the southern hemisphere will be southeasterly. See, trade winds of southern hemisphere will be southeasterly. Polar wind will be southeasterly. Correct? So, any easterly wind of that hemisphere, right, will be having the respective direction, my friend. I repeat again. Easterlies of northern hemisphere will be northeasterly, and easterlies of southern hemisphere will be southeasterly. If you remember this statement, sentence, direction of the wind, very easily you can remember. Okay. The westerly wind is exactly opposite direction, my friend. Right. What is northeasterly? If you take the opposite direction, it will be southwesterly. Correct? And similarly, what is southeasterly? You take the opposite direction, it will become what? Northwesterly. So very easily you remember. Only one sentence you remember, things are fine. Now, my dear friends, where, what wind we have an idea. Okay, simple. We went for one extra mile. Okay. Now I'll just say, for example, okay, we'll just talk about one question which is asked in the past. Okay. So this paper is not available. Okay, I'm just going with this paper which is available in the open site. See, this question was asked in 2015, my friend. Okay. So only thing is that read it and just tell me that what exactly, okay, whether the statement is right or wrong. Okay. If you want me to zoom it, I'll zoom it. Right, my friend. See, read it very carefully, my friend. Read it very carefully. The statement one. Okay. The statement one. Simply, you have to tell me whether the statement one given is right or wrong, my friend. Okay. You first tell me whether the statement given is right or wrong. Then we'll just go for the say, for example, if it is right, why it is right. If it is wrong, why it is wrong. We'll discuss. Just read the sentence, right? And somewhere see, right, whether the statement is right or wrong, my friend. The wind which flows between 30° north and 60° south latitude throughout the years are called as throughout the year or known as westerlies. Is this statement right or wrong? Okay. Yes, right. Okay. People say right, correct. Okay. Is there any other, say for example, any other viewpoint opinion? So Pankaj says it is right. Is there any other opinion, my friend? A wind which flows between 30° north and 60° south throughout the year is known as westerly. Okay. Now you know the sentence. I'll show you this image, what exactly we are discussing. Okay. Now again, a wind which flows between 30° north and 60° south throughout the year is called as westerly. Is the statement right or wrong? Pankaj says it is right. Any other viewpoint? Give it a try, my friend. Okay. Good attempt, but let me tell you, my friend, this statement, see, simple statement, okay, it is wrong. You got it, right? It is wrong. If you ask me, see, on the face of it, if you see that this statement stands to be right, my friend, okay. But if you read it once again, you will understand it is not 30° north to 60° south. It is 30° north to 60° north, or 30° south to 60° south, my friend. It is not from one hemisphere to another hemisphere. Correct? It is not south here, right? It is north. And I'm telling you, this is one of the easiest questions that can be asked in the examination. But the problem, this question during the examination times becomes very difficult. Because see, small things you do not see it very carefully in the examination. What we'll do, right? Normally we'll read, okay, 30° and 60°, and you perceive that yes, it is right. Right? It is not the case. Right? Small things has to be taken care. Right? So, my dear friends, very silly question, very small question, but it's a trap. All right. That's the reason normally we say examination, right? That emotional stability, composed nature is very important, my friend. Am I right? So do not take a decision until and unless you read the statement completely. Okay. So one sample question which is asked in 2015 preliminary examination. Okay, right. So right, my friends, coming back to our planetary winds. Okay, right. So what is the direction in its flow? What direction it flows? Right. What are easterly wind? What is westerly wind? Everything we have an idea. Now, what we'll do, my friend, see, these latitudes has some nicknames, my friend. Now, what I'm going to do, very carefully, I'm going to add those nicknames, correct? Like alternate name, you can call it as. Say, for example, for that case, this equatorial low is very popularly called as doldrum. It's called as a doldrum, or sometimes it is also called as ITCZ. I'll tell you that why exactly it is called as ITCZ, why it is called as doldrum, I'll explain it. Okay. Similarly, 30° north and south, very popularly you call them as what? Horse latitude. It is called as horse latitude. It's called as a horse latitude. I'll also tell you there is an interesting story behind why exactly it is named as horse latitude. And subpolar low, sometimes it is also called as mid latitudes, my friend. Mid latitudes. The balance, even this mid latitude, I'll not add it. Okay. Only thing is that what is this doldrum? What is this horse latitude? I have to understand. Okay. So the next, we'll try to understand, right? Somewhere, what it is called as doldrum. Right. Or sometimes you call them as what? ITCZ, my friend. Right. You call them as a doldrum or you call them as what? ITCZ. See, doldrum or ITCZ is the other name what we use it to refer what? Equatorial low, my friend. Okay, say for example in that case, right? Say for example, you always know, when I talk about equatorial low, my friend, equatorial low, generally that region that exists between 10° north to 10° south, right? Where right at the center you also have this equator, correct? The region that exists between 10° north and 10° south, very popularly we call them as what? Equatorial low. And any low pressure, you know the fact, any low pressure is the outcome of what? Rising convection. High pressure is the outcome of what? Subsiding convection, my friend. So in that regard, so when I talk about this low pressure is the result of what? Rising convection, my friend. Throughout the year, what you experience is a rise of air mass throughout the year. Right, throughout the year, my friend, you'll be having air mass which is rising continuously. Okay, what you'll be having is what? Rising convection. Okay. And my dear friends, of course, I know the fact, right? This low pressure is the place where I have the convergence of two winds. Am I right? What are the wind that converges with this low pressure? If you ask me, one, the wind which comes from northern hemisphere and the wind that comes from southern hemisphere. The wind which comes from northern hemisphere, you call them as what? Northeastern trade. You call them as what? Northeastern trade. And the wind which comes from the southern hemisphere, you call them as what? Southeastern trade. Now, everything is fine. Okay. So equatorial region, doldrum, what happens? You know, this equatorial low is sometimes called as doldrum or sometimes called as ITCZ, my friend. Doldrum is a navigational terminology. ITCZ is a climatological terminology. Okay. First, I'll tell you what is this ITCZ first, my friend. You ask me what is this ITCZ? ITCZ itself, right? It has an abbreviation. All right. What this abbreviation stands for, if you ask me, ITCZ, right, stands for Intertropical Convergence Zone. It is known for Intertropical Convergence Zone. Okay, ITCZ, my friend. Intertropical Convergence Zone. Now it has a meaning, right? If I just talk about ITCZ, you can also take one small paragraph of this ITCZ. I'll tell you later, right? See, name itself. See, that's the reason always every time I say geography. If you want to understand geography, at least for competitive examination, see, one more thing. You should always understand. Like what I am teaching here is not the subject to geography. I am just simply teaching geography for competitive examination. That's it. All right. That's the reason normally say, for example, when academicians almost go through this video, you may not find it useful. All right. But I'm telling you, this is the crux of competitive examination. Always see, it's diagonally opposite, right? How exactly academicians, right, see this competitive examination and how exactly the competitive examination approach is all about. Always there is an inconsistency, my friend. It is more like an oxymoron. Okay. Whatever be the case, our approach is completely with competitive examination strategy approach. Correct? Right, my friend. Right. So when talk about intertropical convergence zone, name itself gives you a clue, my friend. Inter means what? Two or more. Convergence zone. See, convergence zone simply means low pressure. What happens at low pressure, my friend? Air mass will try converging, right, at the place of low pressure. Everywhere, from everywhere, the air mass will be moving towards a central mass. All right. So wherever a depression is there, air mass will be converging there. All right. So my dear friends, any low pressure is a convergence zone. Any high pressure is a divergence zone, my friend. I repeat again, very important. Whenever you come across the word convergence, convergence means, right, or I would say any low pressure is a convergence zone. Any high pressure is a divergence zone, right? It means the air mass will diverge, right? Convergence will be the destination area, right? Divergence will be a source area. Okay. Now, my dear friends, revisit this statement again. Intertropical convergence zone. It means this is the place where two or more tropical wind is converging with each other. Here I don't have two or more. What I have is only two. Correct? Right. So what are the winds that is converging here? Very simple, my friend. Northeastern trade and southeastern trade. Both are warm wind, sourced from almost tropical region. That's the reason you call them as what? Convergence of two tropical winds. Okay. Now, my dear friends, very small sentence or paragraph you can add it. You would have taken this, right? ITCZ. What is ITCZ? Intertropical Convergence Zone. You can write it. It is the other name of equatorial low. It is the other name of equatorial low, where two tropical winds two tropical winds, that is northeastern trade and southeastern trade, northeastern trade and southeastern trade converge with each other. Right, my dear friends, we have justified what is ITCZ. Simple. ITCZ is the other name of equatorial low. See, few books says that outer margins of equatorial low is called as ITCZ, but you simply take it. Right, either you call them as equatorial low or simply you call it as ITCZ. Both are same. Correct? Right, my friend. So what is ITCZ? Why it is called as ITCZ? We have an idea. Now comes the question: why it is called as a doldrum? All right, my dear friends. As I said, doldrum is a navigational terminology, my friend. He asked me what is the meaning of doldrum. Doldrum is a region which is known for prevailing windless condition, my friend. Right? Region of, let me tell you, it simply is a region, windless region, my friend. So windless region, right? Windless region of equatorial belt. So windless region of equatorial belt, right, is called as doldrum. I repeat again. You ask me what is doldrum? Windless region of equatorial belt. Windless region of equatorial belt is called as doldrums. See, comes the question, my friend. See, let us understand in a simple fashion. What is a wind? Comes the very important question. What is a wind? Wind is nothing but what? Horizontal movement of air mass. Movement of air mass. And my dear friends, within the equatorial region, within the equatorial belt, you don't have wind. Only outside this equatorial region, you have a wind, my friend. But within the equatorial region, you don't have wind. What is the technical name for wind? Wind is nothing but what? Advection. My friend, what happens here is what? Convection. Advection and convection do not happen simultaneously. Not only here, my friend. Any pressure system you take it, if you are there in the center of this pressure system, you will not experience wind. Only the outer margins and beyond that, say for example, outer margin, you will be experiencing a wind. Am I right? If you are there somewhere in the pressure system itself, see, entirely it is a low pressure. Entirely it's a low pressure. Within the low pressure, and see, the region is very large. 10 degree north to 10 degrees south. See, always it will not be there. But generally, I understand this region is very large, my friend. Am I right? So, right in this region, you will not have a wind. So, I repeat. So, that windless region of equatorial belt is very popularly called as doldrum, my friend. Now, why there is no wind? Because I understand. You know the reason for it. Why there is no wind, my friend? Because, right. It's all because of what? Because what happens here? It's a domination of what? Convection. All right. Because of, it's all because of what? Rising convection, my friend. Okay. Rising convection. And my dear friends, let me tell you, wherever you do not experience a wind, that region is very popularly referred as a calm region, my friend. Right? You call them as what? Calm condition. So whenever in climatological reference, if you come across the term called as calm condition, my friend, take it for granted that it is windless condition. See, for example, right now, you're seeing outside your window, sun is shining very bright. Okay, very bright. If no tree is moving, if nothing is moving, so somewhere you can almost say, for example, come to a conclusion that rising convection is taking place. So this condition, windless condition, see, very hot summers, my friend. Hot summer and peak winters, right? Anywhere, not only in equatorial region. If you experience hot summer and peak winters, my friend, you may not have wind. Am I right? Particularly if that region where exactly you are present, if a low pressure or high pressure persist, you will not have a wind. Am I right? So in climatological terminology, calm condition means windless condition. Right? Somewhere you can write it. I'm simply repeating it. In climatological reference, calm condition means windless condition. Okay. Right, my friends. Okay. So what is a doldrum? We have an idea. Okay. Now before concluding it, only thing is that we'll understand what is a horse latitude. What do you mean by horse latitude? See, we know the fact subtropical high, right? Subtropical high is called as horse latitude, my friend. So what is this subtropical high? Either you are there in northern hemisphere or southern hemisphere. Normally we have taken it as 30 degree, right? Now slightly I'll increase because I'll make it as a belt. So that region that lies between 35 degree and 30 degree, my friend, you call them as what? Horse latitude. It is the other name for subtropical high, my friend. It is the other name for subtropical high. And one more thing, you know, this is another place where you have a high pressure, right? It's nothing but what? Subtropical high. And you know the fact that any high pressure is the result of subsiding convection. Correct? We know the fact. Any low pressure is the result of what? Rising convection. Any high pressure is the result of subsiding convection. Okay. And somewhere I know any high pressure is the region of divergence and any low pressure is the region of convergence. Right, my friends? In that regard, if you ask me, what are the wind that diverge away from subtropical high? If you ask me what are the wind that diverge away from subtropical high? Towards the lower latitude, my friend. Okay? Towards the lower latitude, you'll be having a wind that diverge. You call them as what? Right. Trade winds. All right. You call them as a trade wind. And towards the higher latitude, you have the wind which moves towards the higher latitude. You call them as what? Westerly. Okay. And of course, I understand right in this region, what you experience is what? Subsiding convection. Everything is fine. Just to construct the opposite of the equatorial low. The equatorial low, it is a rising convection, it is a convergence. Subtropical high is a subsiding convection and it is a divergence. Am I right? No. So calm condition is basically equilibrium pressure condition. No. It is not an equilibrium pressure condition, my friend. Pressure difference will always exist. Okay. There is no place on earth where you will be experiencing equilibrium, and even if equilibrium exists, that is only for a short-lived condition. So where it can happen and when, but when, okay, we know that ITCZ move along with the sun's position. Yes, you're right. Step by step we'll go for it. Okay. Right now you take it that ITCZ is constant. Right now you consider that ITCZ is confined only to the equatorial region. The next step we'll try to make ITCZ move with the sun's vertical position. Right, not only ITCZ, every pressure belts will be moving north and south of equator. Sorry, north and south. During summers, every pressure belt will be shifting north, and during winters, every pressure belt will be shifting south. So I'm just answering the question which was asked by Thaba. Right? Okay. Fine. Right, my friends. So somewhere I have just constructed what happens in horse latitude. And my dear friends, construction is very easy. All right. See there, I was very specific in here in Doldrum. I was very specific. I have mentioned as 10 degree north and 10 degrees south because I know there is only one Doldrum. Correct. But when I talk about horse latitude, there are two horse latitude. Northern hemisphere also you have a horse latitude. Southern hemisphere also you have a horse latitude. That's the reason I have not mentioned the latitude specific. Whether it is north or south, I have not mentioned. Whether it is northeastern trade or southeastern trade, I have not mentioned. Whether it is northwestern or southwestern westerly, I have not mentioned. Right, my friends. Now again, let me tell you, subtropical high, like Doldrum, it is also known for prevailing calm condition, my friend. But let me tell you, there it is just a calm condition. But when I talk about horse latitude, right? Horse latitude, it is known for prevalence of absolute calm condition. Now you may wonder, what is this absolute calm condition and calm condition, my friend? Whenever I say absolute calm condition, it means what? Windless and rainless condition, my friend. Windless and rainless condition. Okay. Wind is also not there, rain is also not there. But equatorial region, what will happen? Wind will not be there. But every day, my friend, almost every day, you will be experiencing precipitation. You will be experiencing rainfall. Correct? But when I talk about horse latitude, no wind, no precipitation. My dear friend, somewhere imagine a condition, you are living in a place where throughout the year you will not experience wind, throughout the year you will not experience precipitation. The purpose of living itself is defeated. Am I right? So kindly vacate the place if at all if you're experiencing that situation, right? So something like that. If you ask me, right, absolute calm condition means what? Windless and rainless condition. Now one thing, why horse latitude? Okay, wind. Why wind is not there? We know idea. I mean, we have the reason for it. Because wherever convection is taking place, convection and advection will not take place simultaneously. My friend, you know that. Either you will have convection or you will be having what? Advection. Both will not take place simultaneously. That I know. Why there is no wind? I understand. Because it is convection. Whether it is rising convection or subsiding convection, that doesn't matter. Wherever convection is there, vertical movement of an air mass, you call them as convection. Wherever convection is there, advection will not take place. Correct? Right. Now, my dear friends, whenever you experience a rising convection, whenever air mass rises, it will result in cloud formation. Right? That cloud will be resulting in what? Precipitation. That's a funda, very simple. In troposphere, if you ask me, how clouds are formed, whichever way, my friend, I'll tell you what, I'll show you. How clouds are formed, if you ask me. There are different ways how exactly clouds are formed. Okay. Say, for example, you call them as orographic precipitation. What exactly you're seeing here is orographic precipitation. See the arrow mark, my friend. Right? See the arrow mark. Okay. I'll just go for a better diagram, right? Where exactly all these diagrams you have it in one head. Different ways that how exactly the clouds are formed, my friend. Okay. Right? Say for example, the very first one, what exactly you're seeing here, the air mass is moving with the help of the mountain. Am I right? Air mass is rising. Somewhere you see the arrow mark, air mass is rising. Whenever air mass rises, cloud formation. Again, the second condition, air mass rises along the front. We call them as a front. What is front? We'll understand later. Again, the cloud is formed. The third condition, on its own, what exactly we are seeing now? Am I right? Equatorial region. Right? The air mass is almost rising on its own, my friend. Whenever the air mass is rising on its own, or whatever be the case, whenever the air mass is rising, there all you will be having cloud. So what is the idea? When air mass rises, you will be having a cloud, right? You will be having precipitation. Right? When air mass subsides, you will not have precipitation. My dear friends, the basic difference between doldrum, right? And horse latitude, right? Doldrum, somewhere you can write it. No wind, but you will have precipitation, right? But when I talk about horse latitude, it is no wind, no means precipitation. All right. So windless and rainless condition, my friend. Now, everything is fine. I understand. See, somewhere, normally, my friend, most of the places, see, for example, throughout the world, what is very common? Summers is known for precipitation. Normally, summers will be wet and winters will be dry. One of the reasons why summer is wet and winter is dry, if you ask me, winters, what you will experience is a subsiding convection. What you will experience is a high pressure. Any high pressure is known for rainless condition. On the other hand, my friend, summers, what you will experience is a low pressure, and any low pressure is known for what? Wet condition. This understanding is somewhere important. Okay. Now remember this understanding, my friend. Okay. Okay. Now, right. Only thing is that we have to justify what is horse latitude. My dear friends, today we have a modern propelling mechanism. Say, for example, when I talk about navigation, how exactly a ship will travel from one place to another, we know it is mechanized boats, ships, everything. It is completely mechanized. All right. But when I talk about the olden days, to be very precise, you would have heard about this age of discoveries, right? Where the new sea route was discovered, when new land was discovered, right? Continents like Americas was discovered, continents like Oceania was discovered. All right. So when I talk about the human settlement, what exactly? See, for example, where the people have moved from one location to another location, from Europe to Americas, from Europe to Australia, and so on, right? My dear friends, I understand during that time, right, the age of discovery or post age of discovery, the common, say for example, force which was propelling this ship was what? Wind, my friend. To be very precise, prevailing wind. Prevailing wind is that, say for example, force which was propelling the ship, right? That's the reason they call them as a trade wind. This wind is used for trading purposes. All right, how exactly people move from one continent to another. All right. In that regard, my friend, normally I have an understanding. See, it means in that case, ships will be facing a very big difficulty crossing this latitude. Because I understand. See, hardly ships crossed Doldrum because the trade relation between the northern and southern hemisphere was almost negligible. But when I talk about horse latitude of northern hemisphere, my friend, often they traveled, they crossed this latitude. But I know, right, crossing this latitude is going to be very difficult because there is no wind. If wind is not there, human effort has to be put in. Am I right? So manually, mechanically, you have to row this ship. Rowing a ship by human effort is very difficult, my friend. All right. So of course I understand. Right, it's going to be very difficult and challenging for the sailors and navigators to cross this latitude. So what they have done, right, what exactly as the convention they followed during that time, my friend? During the post age of discovery, the most commonest traded livestock was horses. Was horse. So what they were during that day, means what they were doing, doing during that time in sense. Whenever they faced difficulty in crossing this latitude, right? Somewhere, all the ailing horses, dead horses, they started throwing those horses into the sea. Why? In order to make the ship light. Okay. So once, only see, nobody is going to throw the good horses, am I right? Horses which is already dead, right? Horses which is, say, for example, ailing, which is about to die, they have the habit of throwing that horses into the sea, right? Say, for example, just to make this ship light so that navigation slightly becomes easier. So what happened, my friend? This habit has become more like a convention, right? And almost, say, for example, almost everybody started following the same. All right. And indirectly, if you ask me what exactly has kept this name, I would always say all those horses which is now resting in peace, my friend. Okay, which were thrown into the sea during that time, during that place. Right? That's the one which has given this name called as horse latitude. Okay, by convention we started calling it as what? Horse latitude. Okay, so that's a reason for naming this latitude as a horse latitude. Okay, right. Now my dear friends, planetary winds, what is the direction? What are easterly winds and what are westerly winds we have taken it? What is a doldrum wheel? Equatorial region is otherwise called as doldrum. Navigational terminology. Climatologically, you call them as what? ITCZ, Intertropical Convergence Zone. Right? What is ITCZ? What is doldrum? Both we know. What is horse latitude? Other name of subtropical high. Doldrum and horse latitude both are the regions where you do not experience wind. But one difference, horse latitude, it is subsiding convection. So there is no wind, no precipitation, no rainfall. On the other hand, doldrum rising convection, wind will not be there, but what you will have is what? Precipitation. That's the basic difference. Forget about the story, forget about the explanation, but these terminologies and what we have written here is very important. Note it down. Okay? Right, my friends. With this, we are just completing this planetary events. What next we have is what? Regional wind, I'll just leave it. We'll just start with the local winds, my friend. Okay. I'll just start with the local winds, right? Local winds of the world, some common names we'll start it, right? I'll start with a common name and so on. Okay. I'll just take a small break, my friend. 2 to 3 minutes break, we'll take it. I'll come back. So time is 5:59. Right, we'll do that 40. Sorry, 3:59. Sorry, excuse me. Right, my friends. So the planetary winds we have done it. Regional winds we'll just save it for the later study. Now I'll take it to the local wind. And see, again, this local wind is also equally important. Small area winds, which is confined to a very smaller regions. Collectively, we call them as a local wind, and they take specific names, my friend. So every region, this local winds will take its own name, right? As I said, it takes a specific name. Correct. Say for example, and we have different categories of this local wind, and I'm going to tell you, right? Let me tell you that this is one very important area of competitive examination. Not only planetary winds, my friend. Let me tell you that that's the reason I do not know, right? Very important. Entire wind as a topic, you can mark it important, my friend. Yeah, we have marked it. Okay. Now here, when talk about local winds, there are some winds, right? Say for example, they'll be there throughout the year, right? But confined to a particular regions. In that sense, they take a very common name, my friend. In that regard, right? We'll talk about some of the winds. What I call them as what sea breeze and land breeze, my friend. We call them as what sea breeze and land breeze. Right, sea breeze and land breeze. Name itself gives you, right, the clue that what exactly is a sea breeze and what is a land breeze. Okay. See, as you know, repeatedly I say this: the wind is always named from where exactly it comes from. Right? It means what? A wind which comes from the land, you call them as land breeze, and wind which comes from the sea, you call them as what? Sea breeze, my friend. Okay. So the very first type of wind, let me call it as what? Land breeze and sea breeze. Name itself gives you a clue, right? Sea breeze and land breeze. Only things that I should understand when you will be experiencing a sea breeze and when exactly you will be experiencing a land breeze. In that regard, my friend, say it's all about the day-night difference, my friend. Say, for example, I am there in a coastal area. Idea itself says you will be having land and sea breeze only in the coastal regions. Okay. Now you are there in daytime. Okay. And now you're in night time, my friend. Daytime. And the same thing you have to put it in what? Night time. Okay. Day and night. Okay. Day and night, my friend. See, for example, you are there during a daytime. Say, for example, you have a land, and adjoining land you have a sea. You have a land and you have a sea adjoining, my friend. You have a sea. Correct. You simply almost say, for example, apply the logic, my friend. During the daytime, between land and sea, right? I always understand that it means land will experience a low pressure, because what happens? Land will experience a warmer condition, my friend. Land will experience a warm condition. So as the case, land will have a low pressure and sea will have a high pressure. Because I understand, daytime land will be comparatively warmer than the adjoining sea area. Correct. So what happens? A low pressure will be created over the land and a high pressure will be created over the water body. That's the reason, right? During daytime, what you will experience is a wind that flows from sea to land. Correct? Very popularly, the same you call them as what? Sea breeze, my friend. You call them as what? Sea breeze. Now you take, for example, the reversed condition. You're during the night time. See, why land will become warmer during the daytime? Because water has the ability to maintain temperature, my friend. Water will neither become too cold nor becomes too hot. Water always has the ability to maintain temperature. So in that regard, my friend, nighttime what happened, right? Say for example, land will become cooler, my friend. Relatively, sea will become what? Warmer. Correct? Right. So wherever you have a cool condition or a cold condition, there you will experience a high pressure, and in the sea what you will be experiencing is a low pressure. Okay, so what you will have is a reversal of wind which flows. All right, you'll be having a reversal of wind which is flows, my friend. So during the daytime, right? Sorry, excuse me. During the night time, right? So you will be having a wind which flows in the reverse direction. All right, a wind which flows from what? Land to sea. You call them as what? Land breeze. Right? You call them as what? Land breeze. Okay. You call them as a sea breeze. You call them as what? A land breeze. My dear friends, even in examination, you can construct it and you can arrive at an answer if at all, if the question is asked in the examination. The question is asked. Okay. Otherwise, my friend, if you're there in a coastal region, see what I'm just giving you is our own example. Right. When I say our own example, we are there in a lower latitude, of course, very near to the coast sometimes. Okay. And if at all, if you're there in the coastal region, my friend, see this, you can see it also. Particularly when I talk about fishermen, right? Fishermen who's not using a mechanized boat, right? Who's using a very primitive, right? A country boat where exactly he'll be having his manual rowing, am I right? Normally, you will be seeing that fisherman normally ventures into the sea during the night time and they will come back to the land during the daytime. Right? If you ask me why, because they are taking the natural advantage of land breeze, my friend. Land breeze will take the fisherman away from the coast. Sea breeze will bring the fisherman back to the coast, my friend. You're there in a coastal region, very easily you'll be finding it. Right, night time you'll be finding that fishermen will be venturing into the sea, and early morning or morning time, right? Not early morning in a sense, right? As the day advances, they'll be returning back. Why? They are making use of this land and sea breeze. Okay. So we are considering the atmosphere over the land and sea, or land and sea itself. See, we are actually considering the atmosphere over the land and sea. But when I talk about sea, one thing I should understand, we are standing in land, correct? We are also experiencing this breeze and wind. Okay, my dear friends, this is the place where atmosphere and lithosphere interact with each other, correct? Somewhere you should understand it. This is a surface. When I talk about wind, my friend, horizontal movement, this wind will be having its impact on this surface, correct? This wind has the ability to move the objects in the surface. And another 2 days, it means the west coast of India will experience a cyclone. Cyclone is an atmospheric condition, but this atmospheric condition will be having its effect on this lithosphere. Okay. I'm answering a question that is asked. Okay. Then will terrestrial radiation play a role in it? Of course, my friend. Very first class itself, we have taken it. Everything is the outcome of terrestrial radiation. Everything is the outcome of terrestrial radiation. When I talk about water, terrestrial radiation is weak. When I talk about land, terrestrial radiation is strong. That's the reason. Okay. Right, my friend. So what is a land breeze? What is a sea breeze? We have an idea. Okay. During daytime, what you will be having. During night time, what you will be having. That also we have an idea. Land breeze and sea breeze. Right. And one more thing. If you are there in a coastal area, every day you will be experiencing a reversal of wind. Part of the day, what you will experience is a land breeze. Part of the day, what you experience is a sea breeze. Certainty of wind is very high. Not like doldrum. See, doldrum. And that's the reason, my friend, windmill. You will never find any windmill in equatorial region. Correct. But coastal areas, right, you will be finding plenty of windmills. But even in equatorial region, of course, somewhere, small coastal difference, water difference you may experience. Right? Okay. Right, my friends. Like sea breeze and land breeze, right? What we have as a similar concept is what? Mountain and valley breeze, my friend. We call them as what? Mountain breeze. We call them as what? Mountain breeze and valley breeze. Right. The name itself says wherever you have a tall mountain chains and deep valley, you will be having this mountain and valley breeze, my friend. Only thing is that I have to construct this mountain and I have to know that when exactly I'll be having a mountain breeze and when exactly I'll be having a right valley breeze. So let me construct this mountain along the deep valleys, tall mountains and deep valleys. So assume that this is your mountain and associated valley, my friend. Okay. So what you have is a valley region and what you have is a mountain region, my friend. Okay. You have a mountain and you have an adjoining valley region. Okay. Now see here. Only thing is that I should understand what exactly happens during the night time and what exactly happens during the daytime, my friend. See, for example, when I just talk about night time, okay, night time versus daytime, my friend. See, night time, normally when I talk about night time, understanding says yes, night time, the air mass in the mountainous region becomes extremely cold. Am I right? So somewhere I understand you'll be having a cold air mass, my friend, right? You'll be having extremely cold air mass. Correct. Because I understand entire day mountainous region is going to experience a very cold condition. As the case, this air mass can become denser, right, because of the extreme cold condition. And you know the fact that any cold air mass is heavy in density. Am I right? So what happens? This air mass, because it is heavy in density, this will start descending along the slope of this mountain, my friend. Am I right? This concept of this air mass draining along the slopes of this mountain, very popularly we call them as what? Air drainage. We call them as what? Air drainage, right? Sometimes this air drainage is technically also called as what? Catabolic wind, my friend. Catabolic wind. We call them as what? Catabolic wind. And my dear friends, this air drainage or the catabolic wind is the one very popularly we call them as what? Mountain breeze. Right? We call them as what? Mountain breeze. Okay. Simple. A wind which comes from the mountain. All right. Now you may wonder, right? Is it a wind? That's what your question is. Any air mass which moves along the surface, very well you can call it as a wind. All right. That's the reason you call them as what? Catabolic wind, my friend. What is a catabolic wind, if you ask me? Any wind which is driven because of gravity, right? Any gravity-induced movement of an air mass, you call them as what? Catabolic wind, my friend. I'll make you to write that way. Okay. So, my dear friends, night time, what you experience along any mountainous region is mountain breeze. Mountain breeze. Why exactly you experience this mountain breeze? Very simple. It is all because of what? The density of an air mass. Because cold air mass is heavy in density, it will start descending along the slopes of the mountain. Right? You call it as what? Mountain breeze, my friend. Okay. Now what happens? Throughout the night, my friend, throughout the night, this cold air mass, right, will be filling this valley. Throughout the night, this cold air mass will be filling this valley, my friend. Okay. They'll be filling this valley. Right, throughout the night, because I understand it means, yeah, right. Somewhere, this descending air mass will be filling this valley, right, with this cold air mass, my friend. Everywhere, what you will be having is a cold air mass. Okay. What you will be having is a very cold air mass. Okay. Cold air mass. Because entire night this valley is filled with what? Air drainage, my friend. And that's the reason, see, whenever this air is moving, whenever the air mass is moving along the slope of the mountain, Right. Sometimes what happens, this will also almost take the clouds along with it. See, by the time, that's the reason, early morning, most of the time, see, for example, when you have a chance of camping mountain, say, for example, of course, right, if you're there in a tall mountainous region, my friend, which is having adjoining valley region, you'll be finding that night sky is very clear. Why this night sky is very clear? Because all this air mass will be descending towards the, right, say, for example, valley floor. When air mass is descending along the valley floor, it will also remove the clouds from the sky, my friend. So the clouds will also start descending along the valley floor. Okay. So the sky will be very clear, right? That's the reason, my friend, night sky in the mountainous region will be very clear. You can actually see the visible stars. In plains region, stars are not so visible, but if you're there in a mountainous region during night time, the sky will be very clear. What makes the sky very clear is this air drainage as a mechanism. Okay. And that's the reason. When I talk about, say, for example, by the time right, by the time, say, for example, you're there in the morning, say morning, you'll be finding that it means complete valley, right, is filled with the clouds, my friend. Somewhere, see. So plenty of mountains you can find this, say, for example, such right? Somewhere you can find that almost, say, this valley is filled with the clouds, right? Okay, whatever be the case, I'm just taking this discussion forward. So somewhere I have also justified that why exactly the sky is very clear in the mountainous regions during the night time. I just told you, because this air drainage removes the cloud from the mountainous top. It takes the cloud and settles in valley floor. Throughout night, my friend, it will be taking the cloud and it will be settling in this valley floor, my friend. Okay. So morning, what happens? This complete valley will be filled with the cold atmosphere. Complete valley. Right? So, of course, I'm just going to talk about the daytime. Talk about daytime. Particularly when I talk about forenoon time, my friend, not the entire day. During the forenoon hours. Right? During the forenoon hours, my friend. Why forenoon hours, I'll tell you. Assume that sun is rising, my friend. Okay? Rising sun. And everybody knows the fact that sun which is rising will first heat the mountain slopes, right? Only then the sun coming high in the sky will heat up the valley. A rising sun always heats the mountain slope first. So what happens, my friend? As and when it heats up the mountain slope, right? My dear friend, this mountain region becomes warm. Mountain region becomes warm, my friend. See the difference? Valley floor is cold, correct? Mountain top is warm. So what happens? A low pressure is created along the mountain slope and a high pressure is created in a valley floor. Correct? I repeat again, my friend. Wherever you have a warm condition, there a low pressure is created. Wherever you have a cold condition, there a high pressure is created. Now, as the case, what happens, my friend? You will be having a wind which flows from right high pressure to low pressure. A wind which flows from valley to mountain. Right? Very popularly, you call them as what? Right? You call them as what? Valley breeze, my friend. Technically, you call them as what? Anabatic wind. You call them as what? Anabatic wind. But here, you call them as what? Valley breeze. You call them as what? Valley breeze. I repeat again. So daytime, particularly during the forenoon hours, what you experience is a valley breeze. Why this valley breeze is called as anabatic wind, I'll tell you, my friend. See, whichever wind which flows with the effect of gravity, gravity-induced wind is called as catabatic wind. And whichever wind which flows against the effect of gravity, you call them as what? Anabatic wind. So knowing anabatic and catabatic wind is very important. right? So make it very simple, right? Somewhere. Just want to bring a very simple difference. Should not be complicated. See here, my friend, see. No wind is going to flow without the effect of pressure gradient force. Pressure gradient forces will be ultimately there, right? So every wind, I understand, my friend, that is going to flow along what? Pressure gradient force. But only thing is that gravity will also play a very important role, and result you will be having a katabatic wind. So not only here, my friend, katabatic wind is very common along the plateau slopes and mountain slopes, my friend. Okay, so very important. So somewhere a very small definition of a katabatic wind you can write it. Right, you can write it. Any wind which flows with the effect of gravity, any wind which flows with the effect of gravity is called as katabatic wind. Any wind which flows with the effect of gravity is called as katabatic wind. Whereas a wind which flows against the gravity, a wind which flows against the gravity is called as anabatic wind. Is called as anabatic wind. Right. See, if you understand what is this anabatic and katabatic wind, maybe just for your futuristic reference, right, I'll copy a very basic information. Okay, that should be fine enough. Okay, and my dear friends, see here. I think last class we were discussing about this temperature inversion, right? Temperature inversion. If you remember, we have talked about some of the conditions, right? Where exactly temperature inversion takes place. See, I have given you, with the promise I told you that later I'll be discussing, am I right? Polar region throughout the year, mid latitude, am I right? Apart from this mid latitude, my friend, somewhere I told you, tall mountains, within bracket, what I have just given you is what? Air drainage. Okay? Tall mountains and air drainage we have just given you. Kindly excuse me, kindly excuse me. So, right, my friends, I was just talking about, say, for example, these tall mountains and deep valleys. See, for example, here I have just given you, this is the condition where you experience what? Temperature inversion. Okay, you experience temperature inversion. See, very carefully you look at it. When I was just talking about this sea breeze and mountain breeze, my friend. Okay, somewhere you can also see the condition of temperature inversion. See, Air drainage itself is not temperature inversion, but air drainage facilitates temperature inversion. What is temperature inversion? You increase the height in atmosphere, the temperature also increases. Correct? This is what I call them as what temperature inversion. My dear friends, very carefully you look at this condition. Right? Condition. Particularly when I talk about forenoon hours. All right. Daytime, my friend. Valley will be experiencing cold condition. Mountain slopes will be experiencing warm condition, my friend. You increase the height, temperature also increases. Am I right? Perfect condition of what? Temperature inversion. Am I right? Temperature inversion. My dear friends, temperature inversion is one such condition which facilitates mountain and valley breeze on a day-to-day basis. Very important, my friend. So what is the condition of temperature inversion? That also we have taken, right? So what is mountain breeze and valley breeze? Correct? What is the sea breeze and land breeze? Right? Everything we have an idea, my friend. See, practical utility. Whenever I talk about sea breeze and land breeze, I understand. If you're there in a coastal area, okay, for your reference, I'll just copy some of the image. A simple image. Okay, I think this is simple. Will you cover frontogenesis, ND frontolysis? Right, that is temperate cyclones. Yes, I'll be covering it later stages. Okay. Now, my dear friends, yes, sea breeze and land breeze. Okay. Just for our reference, my friend. Okay. So, what is the sea breeze? What is the land breeze? When exactly you experience it? Everything I have just given you. Okay. So, nighttime, what you experience, daytime, what you experience, everything I have just given you. And my dear friends, let me tell you, wherever you have this coastal areas, wherever you have the mountainous region, this is the place where the certainty of the wind is very high. It means every day you will be having wind. Either you will be having a sea breeze or land breeze during the different part of the day in a coastal area, or you will be having a mountain breeze and a valley breeze in different part of the, say for example, day in a mountainous region. So wind is very certain. And that's the reason whenever I just talk about the, say for example, the wind energy map, am I right? So for example, if I'm just talking about the wind energy map of India, only in two places you will be finding the major wind installations. There, either you will be finding that wind installation, say for example, wind energy production, either you are there in a tall mountainous region, Himalayan region, northeastern state, right, the Piedmont locations of Western Ghats, am I right? These are the places which is known for what? Wind generation. Apart from that, what are the other places? Coastal areas, right? So this is a place where wind energy potential is also very, very high, my friend. Okay, right. So some of the common names of the local winds we have done it, right? Only thing is that, my friends, we have to take the specific names. Okay, specific names we have to take it. Okay, but specific names, right? We'll take it in the next class, my friend. Somewhere I'll just conclude the class today here at this moment. Any doubts you can ask me. Okay, right, my friends. I'm assuming that doubts are not there. The rest of it we'll just take it in the next class, my friends. So thank you. God bless you.